This is Lesson 13, Introduction to Estimation, part of TRAC's continuing education program in Introduction to Statistics with R. Over the next 4 lessons, we'll talk about point estimators, confidence intervals, as well as some hypothesis testing. Statistical inference consists of those methods we use to make generalizations about a population parameter. There are 3 main types of inference: a point estimation, which uses a single value to estimate a population parameter; a confidence interval, which we hope contains the population parameter; and hypothesis testing, which sets up specific hypotheses about the parameter. There are also, let's say, 3 schools of thought about how statistical inference should be done. Bayesian analysis, which goes back to Bayes and Laplace, they believe that any prior knowledge about the population should be taken into account. R.A. Fisher took the opposing view that statistical inference must be based entirely on probabilities with direct experimental interpretation. And then the frequentists, with names like Neiman, Pearson, and Wald, they viewed statistical inference as a decision problem with an associated risk. So a point estimate of some population parameter is a single value used to represent that population parameter. For example, the mean, it's a good estimate for the population parameter mu. S squared is a good estimate for the population parameter sigma square, variance. If you've got a data set in R, in this example, we'll call it data set. If you want to find the mean, you just type mean, open parentheses, data set, close the parentheses, and hit return. Similarly for the variance and the standard deviation. var data set, sd data set will return the variance and the standard deviation. But you should be aware that the variance and the standard deviation here are the variance and the standard deviation of the sample, not of the population. One of the great things that R.A. Fisher gave us was the method of maximum likelihood. The method of maximum likelihood is a way in which we can find a good point estimate of a population parameter. The idea behind the method of maximum likelihood is that we say, of all the values this population parameter could be, which one is most likely to give us the observed data? The likelihood function is the product of the distribution at each observed data point and the population parameter theta. Of course, since we are looking for the most likely value, we're going to have to do some differentiation with respect to our unknown population parameter theta. Setting the derivative equal to 0 and solving will give us our maximum likelihood estimate. Of course, a lot of the times it's easier to differentiate a summation rather than a group of products. So in these cases, we'd like to take the log of the likelihood function before we differentiate. Of course, we can use R to find the maximum likelihood estimate of a distribution. The MLE function is found in the libraries, in the stats4 library, so make sure you have the stats4 package installed and the library loaded before you do the MLE command. Let's say you have a set of data which happens to be a gamma distribution, so we want to create a summation of those gamma distributions at each of the data points. So we're going to use a function that is made up of the negative summation of a gamma distribution. The negative sign's in there so that when we take the minimum, which is what the MLE function defaults to, we get the maximum. And then we use the MLE function on that negative log likelihood function, and the summary of that should give us our maximum likelihood estimate. Another way to find a point estimate is the method of moments. The method of moments compares the first k population moments with the first k sample moments, where k is the number of parameters in the distribution. So I guess for a gamma distribution, we'd have k being 1 and 2 parameters, alpha and beta. We're going to leave the method of moments for you. You can skip it or maybe do some Google research. Find out what they can do with R and the method of moments. I've used the term good a few times through here, a good estimator, so it's probably a good idea to define what we mean by good. A good estimator is one that is unbiased, and by unbiased we mean that the expected value of that estimator is equal to the parameter being estimated. If you happen to have two good parameters, then we like to take the one that has the smaller variance. So in summary, the theory of statistical inference consists of those methods by which one makes inferences. There are three main types of inference: the point estimation, the confidence interval, and the hypothesis testing, and three main paradigms for studying statistical inference: Bayesian, Fisherian, and frequentist. Point estimates are single values used to represent a population parameter, and many point estimates come from common sense. However, the maximum likelihood estimator and the method of moments give us two methods that we can use to find good point estimates. And a good point estimate is unbiased. I'd like to point out that none of the information I've given you during this lesson was my own work. The two references for the course, Kearns and Verzani, of course, and then another reference, Walpole, Myers, and Yee, which should be familiar to a lot of people, but also took information from Young and Smith, Cambridge Series in Statistical and Probabilistic Mathematics, Essentials of Statistical Inference.